Practical Nodal Analysis. Hi, welcome to New Tech YouTube channel. In this video, we are going to perform practical of nodal analysis using multisim software. Let's see actual circuit used in experimental setup for nodal analysis. In circuit diagram, we have selected three resistors R1, R2 and R3 of 10 ohm, 30 ohm and 20 ohm respectively with two DC voltage sources V1 and V2. Also, we are going to select various ranges of DC sources and measuring node voltages VA, VB and VC with voltage across resistor R3 as a VR3 and current I3 through the resistor R3. Now we are performing practical of mesh analysis using multisim software. Let's start. In workspace, we are going to construct actual circuit of nodal analysis. Now, from component toolbox, select two DC sources V1 and V2 and ground. Close the component toolbox. Again from component toolbox, select three resistors, resistor R1, resistor R2 and resistor R3. Close the component toolbox. Orient the resistor R3 in a clockwise direction. Then make a connection. Connect voltage source V1 to the resistor R1, resistor R1 to the resistor R2 and resistor R2 to the voltage source V2. Connect the voltage source V2, resistor R3 and voltage source V2 to the ground. Then select multimeter 1 to measure voltage between supply voltage V1 and resistor R1. Then select multimeter 2 to measure voltage between resistor R1 and R2, called it as a voltage VB. And select multimeter 3 to measure a voltage between resistor R2 and voltage V2, call it as a voltage VC. Then again select a voltmeter to measure voltage across resistor R3. To measure voltage across resistor R3, we call it as a voltage VR3. And again select one more multimeter to measure current flowing through resistor R3. Then change the component values. Resistor R1 at 10 ohm, resistor R3 at 20 ohm and resistor R2 at 30 ohm respectively. Then set voltage V1 at 20 volt and voltage V2 at 10 volt. Then connect the negative terminal of multimeter to the ground, multimeter 2 to the ground. Similarly, multimeter 1 to the ground. Then double click on multimeter 1, it shows its display window. Similarly, double click on multimeter 2, it shows its display window. Multimeter 3, we are measuring is voltage VC. Again, multimeter 4, we are measuring voltage VR3 and multimeter 5 for measuring current I. From sequence like this, we are measuring voltage VA, voltage VB, voltage VC, voltage VR3 and current I3. Then we select a current range. Now start the simulation. We get voltage VA is equal to 20 volt, voltage VB is equal to 12.727, voltage VC is equal to 10 volt, voltage VR3 across resistor R3 is 12.727 and current through resistor R3 is 636.364 milliampere. This is our first set of readings. Then stop the simulation. Again set voltage V1 is equal to 45 volt and voltage V2 at 25 volt. Again start the simulation. We get voltage VA is equal to 45 volt, voltage VB is equal to 29.091 volt, voltage VC is equal to 25 volt, voltage VR3 is equal to 29.091 volt and current I3 is equal to 1.455 ampere. This is our second set of readings in nodal analysis. Then stop the simulation. Now see observations and calculations. We selected various ranges of DC voltage sources V1 and V2 and measured node voltages VA, VB and VC with voltage VR3 and current I3 through resistor R3. And for calculations of node voltages, refer the link given in the description on nodal analysis. Let's see the results of nodal analysis experiment with voltage V1 is equal to 20 volt and V2 is equal to 10 volt as result 1. Observed value of voltage VB is equal to 12.72 volt. Result 2. Calculated value of voltage VB is equal to 12.7 volt. In this video, we have performed practical of nodal analysis using Multisim software. Please like, share and subscribe to my channel and press the bell icon to get new video updates. Thanks for watching my YouTube channel. Thank you.